All right. So what I'm going to try and do here is take a part from the body as designed to a toolpath that we can run in one of the mills. I'm going to try and do it all in one shot, all in one take. Here goes nothing. So we have a part here from the robot that we're building. This is the J6 gripper mount. You can see that there are some features that are all accessible from the top, but there are 2 additional holes that we're going to have to go back and do in an entirely different setup. What I mean by setup is we're going to clamp a piece of raw stock into the vise, and it's going to be in this orientation with the tool working on it from this direction. So we will not be able to reach those holes on the side. So while we're talking about stock, in the setup, so if we go over here to this little folder in the manufacturer tab, there's a little button that says setup. So we created a new setup. I named it J6 gripper mount just so that we wouldn't lose it. We have to select a machine, the operation type. The machine I have saved in this computer as a Tormach, because that's the one that we're going to be using today. The running down through the options here. The Z-axis, which is this blue arrow, we want that to be running up and down. We want that arrow to be pointing up specifically. The X-axis, we want to be pointing to our right, and the Y-axis, we want to be going away from us. So all of those things are correct. We want the origin. I like to put it in the back left corner. Some people work from the center. I like putting it on the stock box at the back left corner. So the stock that we are using, and I know you won't be able to see too terribly well in the tiny little talking head in the corner, but there's a little piece of stock that I have already cut to roughly the correct height. So we know we're going to go to stock, which is the yellow thing. I'm going to go to fixed size box, and we're going to put in these dimensions. So the X, let me put my phone on vibrate here. The X dimension is our left to right dimension. So I'm going to measure that with our calipers, make sure that they're zeroed first. So the calipers are zeroed. And going left to right, which is going to be this way, we have a measurement of 2.006. So I'm going to put that in here, 2.006. The depth, which is our forwards and backwards position, we have a measurement of 2.062. And finally, the height, which is our up and down direction, we have a measurement of 0.976. Okay, so that gives us the outline of this block of plastic that I've got in my hand. So you can see we've got some extra plastic, a little bit wasteful on this particular one, but that's okay. It's going to be entertaining to do. So what I want to do on this one, I'm fine with its X and Y position. That is, it's centered. You know, some model position is listed as center on the X and center on the Y. I'm fine with it being at the center of the part, but I do want to raise the model up in the block. So looking at it with our X-ray vision, I want the part to be more towards the top of the block than it is towards the bottom of the block. That way I'm not doing any machining operations really close to the vise. So on the Z, we're going to tell it offset from the top. And I don't know, 20 thousandths, 0.02. Why don't we do 50 thousandths? So 50 thousandths of an inch is 0.05. So that's going to move our part closer to the top of the top of this block of material. What that's going to do is keep the cutter away from the vise. We don't we can stress a little bit less about crashing the tool into the vise. Our third option over here is post-process. We really don't need to mess with this. This is program name and number, program comment, and then which work offset we're using. We're just using the default work offset, so that's all okay. So we're going to hit OK on this. And so now we need to figure out how is it that we are going to get all of this extra nonsense away from how are we going to get our part out of here. So the first operation that we're going to do is called a facing operation. And if you hover over any of these buttons in Fusion 360, it gives you a tooltip. So it produces a quick part facing to prepare raw stock for machining. A facing operation removes all material from the top of the stock to the top of the model. So I'm going to make a new facing operation. Running down this list, we're going to select tool number 4 because that's what's in the milling machine right now. I have that saved in the mill, in Fusion as number 4. I have it saved in the mill as number 4. I also have a cutting preset for Delrin, which is this plastic. So that gives us all of our information, speeds and feeds, and how fast it should be turning the spindle. Notice the spindle should be spinning at 5,729 RPM. It should be moving at a surface speed of 375 feet per minute. I'm going to change this ramp spindle speed. I need to change that in my defaults because I noticed that was lower than it needed to be. So what I'm going to do is come in here to my presets and ramp spindle speed. I think I'm just going to make that 6,000. So the ramp spindle speed is when we're not touching, we're not cutting, we're not doing anything, and we come down and contact the part. For some reason I had that set lower, so it sounded like the machine was bogging down when we went into a plunge cut. So actually I just made it a little bit higher, so it's going to spin up a little bit faster before it goes and plunges. Now, Fusion, if you make a change to that default, Fusion does not seem to, nope. It wants me to reload the tool before it saves that ramp spindle speed, but I can change it right here. So, all of this is calculated on one of the online calculators, or feed per tooth, or lead in feed, or lead out feed, or ramps, feed per revolution. Everything is set up. I do have coolant disabled, so it's not going to spray coolant everywhere. So now we can go to geometry. I believe, if I'm correct, I don't have to select anything. Our heights, so we have our clearance height set at 0.6. We have our feed height set to 0.2, our retract set to 0.2, and our top of our stock is 0 inches, which is where we're going to set our Z0. And the bottom of this cut is negative 0.05, which is at 50 thousandths, where we place the model inside the thing. We can do this all in one pass. It's not a big deal. So we're going to hit OK. Now it's going to automatically generate the toolpath for that. And here's our first operation, our first toolpath. So if we want to hit simulate, we can hit simulate and push play, and it will show us what it is doing. And there's a little thing here. We can drag the speed up. So the blue, right now I have the colorization set to comparison. So blue is stock that's left over. Green is final dimension of the part, and red is whoopsie, you went too far. So as we're going through this facing operation, you can see that we're just knocking the top off the part. All right, so there's the end of our first operation. Now there's also a time listed over here, 36 seconds. So if we had already faced this part off, which I actually already have, but if we'd already faced this part off to our satisfaction, we could save 36 seconds on this, this operation by just not doing that anymore. Excuse me. So from the facing operation, we're going to go right-click on that. We're going to go to create derived operation, and let's do a 2D adaptive clearing. So that's this button here. If we hover over it, it'll tell you it's a roughing operation. Roughing mean we're not going to final part. That uses a more optimized toolpath that avoids abrupt direction changes. So we're going to do this 2D adaptive. We have the same tool selected. We have all of the same defaults for our speeds and feeds. For our geometry, we are going to select this. Now you notice this arrow is on the outside of this sort of island in the middle of our part. That's what we want. If we click on that arrow, it switches to the inside, and that's going to cut the exact opposite of what we want to cut. We do not want that. So there's cutting that. We're going to set our heights. We've got a retract height, or clearance height, retract height, and top height are all defaults. Bottom height is our selected contour, which is this guy that we selected there. Our passes, so how many passes are we going to take? We're going to try and yeehaw this all at one time. Notice the tool tip when I hover over it. Or we're going to try and do it at multiple depths. Now I know from cutting on this stuff the last couple of days that we can probably hit it all at one time. Out of paranoia, I'm probably going to do it, let's say a 1/4 inch at a time, 0.25. Now we are leaving a little bit of extra stock. Let's see. So we're going to leave a little bit of extra stock radially. Radially means that we're not going to our final dimension on the outside of this island, but axially we are going to our final dimension height-wise. Smoothing removes excessive points and fitting arcs where possible within a given filtering tolerance. I don't think we need to worry about that. Feed optimization, feed should be reduced at corners. I don't think we need to do that. So we should be able to hit OK and have toolpath generated 1 minute, 11 seconds. And you notice that when we go to simulate, now I have the 2D adaptive selected. So when I go to simulate, it's going to pick up right where we left off on the facing operation. We don't need to watch the facing operation over again. We know what it looks like. So here we go. Yeehaw, going all the way around the outside of the stock. It's looking a little jumpy on my computer here. It may be that trying to record this and simulate all at one time might be making my computer upset. So let's give our computer here a little boost while that's running. Like I said, you notice that we're leaving some meat around the island there so that we can come back and clean that up. With this plastic, I don't know that that's necessary, but when we get to doing aluminum, it's my understanding that that will be necessary. So I'm going to speed it up. Whee! Okay, so there's the end of that toolpath. So we're down to where we want to be on this. We're to final depth here. We're to final depth here. We still need to trim the outside of this. And I think what I'm going to do is go back and edit this toolpath. So if I double click on it, I can edit this toolpath. And let's go back and let's get rid of that radial stock to leave. Let's just go ahead and make it final size. So it'll regenerate that path. We can resimulate and play it at super high speed. So now we're to our final size on everything except that little indentation. So we need to figure out, let's go back to hit close on our simulation. Let's go back and figure out why it is that we are not getting. So I think this minimum cutting radius Okay, that's what I thought. So this minimum cutting radius is preventing us from getting to that. So we're going to set that to 0 at the moment. I think that'll be okay. And okay, regenerate. I still think there's a little bit of material in there, but let's simulate and find out. That's the nice thing about these simulations is that we don't have to waste material to find out. So it seems to think that it cannot get into that corner. So what we would do to fix that is switch to a smaller tool. Let's go double check one more time, see if there's any other option we can do. Load. All right, for the moment, we're going to leave that. So now we're going to go right-click, another derived operation. We're going to do a 2D contour, and we're going to go all the way around the bottom of the part. And I don't know why it has two things selected. We don't want two things selected. I didn't think we did. There it is. Okay. Heights, select contours, passes, and linking. It should just be. So now there is a thing happening here where for some reason it is doing some passes in an area it doesn't need to. So we need to go back into our toolpath and say no, no, no. I think that's in our passes. Yeah, we don't need to do multiple depths because we've already machined that. So let's start all the way at the beginning and go to simulate. Play it at super high speed. Still not happy it's leaving that little piece there, but we'll deal with that. So now we have cut all the way around the part. We need to double check our axial stock left to leave, make sure that it cut all the way down to the bottom, all the way to the bottom edge of the part. So we're going to go back and check that, and then we're going to see what we can do about these holes that need to be drilled as well. So let's go back to our 2D contour, make sure that we are not leaving any stock. We are not. That box is unchecked, so that's okay. Still not happy with this. So there's an option in here called rest machining, which limits this operation to remove material that a previous tool or operation could not remove. So if we go and add a if we go and tell it that we previously have cut this with a 1/2 inch or a 1/4 inch thing, which is what we have in there. So we would need to add another tool change, go down to a smaller tool, which I probably will do just to get those get those knocked out. So we have a facing, a 2D adaptive, a contour. So we're up to maybe 2 minutes on this part. So let's see, we need to deal with these holes. So this hole here in the middle, if we go to inspect, click on the tape measure, click on the hole, it'll tell us that the diameter of that hole is 0.236. The tool that we are using to do all this, tool number 4, is a 1/4 inch end mill, which is 0.25. So our 1/4 inch end mill will not cut this hole. The end mill's too big. So we will have to switch to a different tool to handle that hole. This one, let's see, give me the hole. All right, inspect, select the hole. It's a diameter of 0.098, so obviously we can't do it with that tool. So we're either going to have to switch in some drill bits or switch into the 1/8 tool. And while I'm thinking about it, the 1/8 tool, so if we convert 1/8 to to a decimal, it's 0.125. So the 1/8 tool will not drill this hole either. So we're going to have to switch over to a drilling operation in order to make that happen. And we have to pull out some drill bits anyway to do this thing. So let's add an operation. So if we go over here to drilling, there is an option here for hole recognition. It automatically finds hole features in any plane and creates drilling operations. So it is looking at these holes, which are 0.0984. So we are going to tell it to simple drill those. This hole number 4, that's not actually a hole, it's just confused. This hole here is 0.2362. We're going to tell it to drill that. And this hole, again, not a hole. So that automatically creates us 2 tool paths. I'm sorry, not 2. Let's see, one here. Where's this one? Oh, it's got a spot drill coming in. All right, so a spot drill is a super stiff drill bit so it doesn't walk. So we can actually delete our spot drilling operations. We don't need that. Is this also a spot drill? Spot drill, yep, we can delete that. So now we've just got 2 operations, tool 18 and tool 15. So the challenge here is that when we use a drill bit, we don't know beforehand what the length of the tool is going to be. So probably going to save those for a later, so let's just delete those. So we're just going to run these 3 operations on this block of plastic and go from there. So, and then I can always come back because I know where my origin is. And actually once we're, so once we are to this point, we can reset our origin to be at this back corner. This hovering origin up here is where the origin used to be. So we have those 3 operations set up. We go up here to the G1, G2 button, which is post-process. Post-processing saves those toolpaths in a format that our particular machine can understand. So there is a post-processor already built in for Tormach. So we've selected the PathPilot / Tormach post-processor. And we're going to save it in a folder on my desktop called Anon AR3, which is all the files that I'm using for this robot. It automatically chooses the file extension that the Tormach can understand. Here's our program name. So we're going to name it J6 gripper mounts. And we're going to hit OK. It's going to double check with us and ask us if make sure we save it where we want to save it. So now if I go to that folder on my desktop, stop, and then J6 gripper mount. So this is the file that we're going to transfer over to the Tormach. Goodness, it is very short. Here's the 2D contour. Oh, it only saved the one operation that I had selected. There's a goof for you. So let's go, click on J6 gripper mount. Let's do post-process. It only exported the one that I had selected. So J6 gripper mount and post, save. It already exists. Yes, it was incorrect. Let's go back to here. Open it up. Now we have facing operation. Scroll down. We have a 2D adaptive. And we should have a 2D contour. Goodness gracious, way down here somewhere. So our operations are all in there. Close that. I have a USB drive that is that we only use for the Tormach. It has some of the Tormach updates and things like that. So USB drive says Tormach. It's always said Tormach. Why would you think otherwise? So we are going to send this to there. So now on our USB drive, we have J6 gripper mounts. It's always good practice to eject your flash drive after you are using it. All right, so let's switch over so that it is just recording my screen. There we go. All right. You're coming with me. Okay. So the first thing we're going to do is look at PathPilot and look at getting this file into PathPilot, and then we'll get the stock in there and all that fun stuff. I hope that we will be able to kill the glare on this screen. Sort of, kinda. Thanks, fluorescent lights. You're awesome. All right. We'll work with the glare. It'll be fine. So I'm going to plug that into the USB drive into the Tormach, into the computer that's underneath the mill. Nope, that made it worse. That's livable. All right, so on our touchscreen here, if we go to File, it's already brought up the USB drive on this side. So we want to select J6 gripper mount. We're going to copy it over to this side, which this is the computer or the controller. This is the USB drive. So now we're going to scroll down. J6 gripper mount is right here. We're going to say load G code. And here is the code that we made. And you can scroll around on it, look at it. In any case, there it is. So now that is loaded onto PathPilot, now you get to go in the mill. Here you go, come with me. Okay, so yes, there's chips everywhere. We're going to make sure that there are no chips on the surfaces that the piece of stock is sitting on. So here we've got a set of parallels. I'm actually going to swap out for. Remember, we moved the part further up in the stock so that we wouldn't be getting close to these jaws. That means I can use a smaller set of parallels, and I can get more grip on the stock so that we don't accidentally sling the stock out of there. So make sure my edges are clean, and grab my chunk of stock. Make sure it's oriented correctly. So I have set this vise up. I've already set the zeros so that the 0 on the y-axis is the back edge of this jaw back here, and the 0 on the x-axis is this the edge of this magnet here. So because we're not doing super precision, I'm not too terribly stressed about that. So I'm going to push this diagonally into that back corner. I'm going to tighten up the vise. Going to use this hammer. Make sure that that it's down flat against the parallels, and then give it one little tweak on the vise to make sure that it's going to stay in there. So we already have tool number 4 installed. It's a little bit out of your view there, but that's okay. Things we need to do. We need to set the Z0, and then we'll do a sanity check to make sure that our X and Y is also correct. So I've got my shuttle here. I'm going to select Z, and I'm going to jog the Z axis down until we're just barely touching the sheet of paper. So we know that this sheet of paper is 3/1000 of an inch thick. So when we're just barely grabbing it, I don't know if you can hear that on the recording or not, but when we're just barely grabbing it, we know that we are 3/1000 of an inch above the part. So we're not actually touching the part. We're just 3/1000 away. So I'm going to go into PathPilot and tell it that our current Z position is 0.003. And apparently I need to recalibrate my screen. All right, so our current Z position is 0.003. I'm going to tell our X and Y. So we're going to do G0, which is the command to rapidly move somewhere. X, goodness, my screen has gotten terribly off all of a sudden. X, 0, Y, 0. Before we do that, I'm going to move the Z up a little bit. Okay, so we can see that the center of the tool is directly over this corner. So our X0 is here, our Y0 is here, our Z0 is right to the top of the part. That is what we told Fusion 360 when we set this operation up, is that the origin point was at the back left corner of our stock. It's the back left corner, the top back left corner, which is exactly what we just told it. So what I need to do now is throw something across my keyboard so that we don't get chips of plastic all over the keyboard. Since we are not using coolant, I'm not too stressed about it. It's gonna throw plastic chips everywhere. That's gonna be okay. All right, so let's get out of here. Okay, so from this point, we have set our X, Y, and Z0. We have clamped our stock in the vise. Our stock is not going anywhere. We might, let's see, out of paranoia, let's double check before we hit the button. I'm going to go back into Fusion and I'm going to double check the height of the part. Inspect here to here. So the total height of our part is 0.63 inches. And then we put the part 50/1000 of an inch deep into here. So I'm going to go to 0.63. And I'm going to add another 50 thou, which puts us at 0.68. So the deepest this tool should cut into this material is 0.68. And so if I do this and sort of run around here, we're getting very close to that. Remember what I said about switching those parallels out? And I thought that would be a good idea. we're going to go back to the taller parallel, which also means we're going to have to reset our Z height. But that's okay, it's super easy to do. Make sure that our, yes. So this is going to go here. Going to put it in the vise. We're going to take our hammer, smack it down a couple of times. Go here. Very gently, I'm going to take my Z-axis. I'm going to come down. And I'm going to put this here. All right, so we're touching. And we need to tell it that that point is 0.003. Enter. And so now that has moved our Z0 to account for the slightly taller parallels. Now, I just noticed that one of my parallels is weeble wobbling. I'm going to push this part down just a little bit more. It's touching, just weeble wobble. So, grab my calipers again. We know that the deepest cut we're going to make is 0.68. So we're close. We're certainly not going to hit the vise. If we hit anything, it would be this magnet, and I can slide this magnet down. So we shouldn't hit anything. Fingers crossed. Get your piece of paper, cover up your keyboard again. Okay, so fingers crossed. I'm going to put my hand on the emergency stop button for no reason at all, and we're going to hit cycle start on the machine. Now, if I was feeling super paranoid, I could put this machine in a mode where it only runs one instruction at a time. And I'll probably do that for the first half a dozen instructions. So it'll move down to the clearance height and then down to the feed height. Basically, I'll probably have it on single block until we touch the material and we know that we're right on that front, and then we're going to let it rip. So I'm going to close the doors, and we're going to see what happens. So when I open the doors, it pauses the program. That was our facing operation, so that's all done. Next stop.
All right, so in a little less than 3 minutes, it was actually 2 minutes and 58 seconds, not including my interruption. Now, because we're using a known repeatable origin, I can take this part out because I know that I can put it back in the vise using the edge of this magnet for my x-axis, the back edge of this for my y-axis, and I know that I use this set of parallels for my z-axis. So that gives us a part that looks like that. So still have to go back and drill the holes that it needs, and then we'll have to flip this part over, clamp it down in the vise, and face the back of it off, but that is another operation for another day. That is, so far, I'm happy with that. We'll pick back up at another time and finish all the rest of the operations. Thanks.